So hi everyone, welcome to my YouTube channel. In today's video, we are going deep dive into an exciting project uh, which enables the user in e-commerce platform to enhance the user experience using generative AI. So just think about if we have a feature in the e-commerce platform like Amazon, uh, just being able to upload an image of a product which we have with, and we are getting a set of similar images, the product images, which is pretty much similar to the image which we have uploaded. So this is basically a image recommendation system. In this project, user can able to upload the image, and also he can search the image using the query. So these two features we have adding with the help of the generative AI embedding model and the vector database. So basically we have using LangChain framework to build this project. This is a UI of our application where we can search by image or search by query. In search by image, we can able to upload an image. Say for example, I'm uploading an image of a t-shirt, blue t-shirt, and clicking the search button. After clicking the search button, we will get a set of image and details from our catalog, which is pretty much similar to the image what we have uploaded. So next is a search by query. When we click the search by query, we can able to search by some queries. For example, if I type something like I want black shoe for ladies. After click the search button, we will get a set of images which is similar to what we have asked. So basically it will retrieve the similar images from our database. So this is search by query. Let's change this black to blue and see what will be the result from the system. After clicking the search, wow, nice. We got exact blue uh, shoes image from our database. In this way, we can find the product by using search by image or search by query. For this project, I used the React as the front-end framework and Fast API as backend. In this video, I will explain you the backend logic that I have used to build this project and show you how to set up this project. So let's jump into our main code. First, we need to install all the necessary packages which is relevant for our project. In the next snippet, you can see that we are checking our device, its CUDA is available or not. This GPU is available or not. If the GPU is available, we set the device as CUDA. If it is not available, it will set to CPU. So here, why we are using this GPU is nothing but for to improve our computational power. Here we are loading the embedding model to our project. The embedding model what we have using is the Coco V8 L14. This is basically the fine-tuned version of V8 L14. V8 L14 is the parent model which we can check here in Hugging Face site, and this is an OpenCLIP model which will convert the image into the embedding vector. So basic purpose of this embedding model is to convert the product image into the numerical format called the embedding vector, and we need to store this vector into the vector database later. See, in the Hugging Face site, we can find some other similar models like B32 and B16. See, in the performance table, we can find that uh, this V814 is the higher accurate model. 75.4 is the accuracy of V814. So that's why we have using the same fine-tuned model of V814. And here in the code, OpenCLIP embedding from LangChain tool, we have used to load these Coco V8 L14 model, and this is a checkpoint, and we are loading these embedding into this device called or CUDA, or maybe it's CPU, and this is our embedding function. And later this embedding function is used to initialize the Chroma vector store. Here you can see I have commented a snippet. This one also you can use instead of this OpenCLIP embedding, directly adding this checkpoint. If you have already downloaded this embedding model to your local directory, you can replace this checkpoint name with the directory where you have stored this model as the bin file. So basically, the data set what we have used to build this project is the e-commerce product images from the Kaggle, and so it contains the JPG images for of the apparel and the footwears, along with a fashion.csv. This is the metadata of the product, and we are using these metadata along with these image embeddings, and we are storing these metadata like product id, gender, category, subcategory, etc., along with the embeddings in our the vector database. So that's why we are getting when we are querying something about from the UI, and we are getting the images along with the product details. So this Kaggle dataset URL I will be sharing on this video description. Here we have loaded this fashion.csv metadata into a data frame, and this is our data frame look like: product id, gender, category, subcategory, image URL. These all data like product title, all is here. So let's check the shape of the data. It's contained 2906 images. So we have extracting the image names like JPG image names to a variable called image names. So this contains the list of string which showing the image names. So here comes the critical step of our project, is nothing but the loading these images into the vector database. Here you can see the batch size as 100, and we are taking each 100 images and storing it to the vector database. See here, uh, we have looping into all the jpg files inside that folder path, and taking each 100 images and storing it to the found image list along with the metadata in metadata list. Once it's done for one batch, that is 100 images from these 2906 images, uh, it will store these images into this vector store using this add image from this vector store LangChain object. Here we have building these IDs using the UUID from Python, and which enables us to identify the unique images from the data set, sorry, from the vector DB. In add images, we have using the IDs, found images, and metadata, and we are storing this batch into the vector store. So after completing all the batches, there will be still having some remaining images need to be uploaded. So this snippet help us to upload that remaining images. So total we have 28 batches and completed, and we have uploaded all these 2906 images, these embeddings into the vector store along with the metadata. So now let's dive into the real search functionality. This search by image function basically which is um, help to get the retrieve the images while we have uploading the image. Okay, so here in these search by image functions, you can see we are using the vector store, and the URI is nothing but the the URI of the image what we have uploaded, and K is the number of output images that we want to display. Here you can see it performs a similarities search in the catalog, which enables us to find the similar images from our catalog. And here we will get the k number of images, similar images from these retriever, and using these get images we are trying to show these images, retrieved images, along with the metadata. So here we have used the get image function. In get image function we have taken each and every images from the retriever and converting it to the base 64, and using this image from image object from PIL and opening this image and showing this image using this functionality. And along with we want to show this metadata with uh, this images. So that's why we have loading the metadata as the data frame from these retrieved data, and we have showing. So see in search by image function, I have uploaded a chapel.jpg this image, and we have getting some visually similar images from our catalog, the same like what we have uploaded along with the metadata. See, it's pretty much similar to what I have uploaded. Now let's come into an interesting functionality of our project, that we have adding a text-based search option which allows the users to search by query. Like if you want to search some product by like using, you might be need the black shoes for women, or maybe you need some red t-shirt having the image of a particular ship or car, and you will get a set of images from this application. So the basic the logic what we have built to enable this feature is using the search by query function. You can see the function here. We have used a set of multiple retrievers and from the vector data store. The only change is we have changed the search types and search quarks. It's same like we have implementing some conditional searches, like it took first a retriever which is using the search type as a similarity score threshold, having k equal to 5 and threshold score is 0 0.1. It's nothing but it will show you the first 5 most recommended image with score threshold we can set to 0 to 1. So if we set the threshold very less, we will get more image related to what we have uploading. not uploading, what we have querying. uh, the basic thing what happening here is we have adding the query, we have converting in the program, it will convert the query into embeddings, and it will execute some similarity search using the embedded query and the image embedding inside the vector store. So if we couldn't find any images from this first retriever, it will switch to next retriever search type called mmr, and you are using chaos 5 and fetch chaos 50. If we couldn't find anything from uh, that retrieval also, then it will switch to the third retrieval. We have just changing some quarks values as keys as lambda mult. So previously we have used the fetch k, here we have using lambda mult, and this is another type of retrieval you can play around with by changing these values and with different retrievers. Finally we have getting a bunch of images, the data from uh, these retriever. It is basically contains the image along with uh, these metadata. The same get image function we have used here also to display the image and metadata. See here I have search, enable some search like black shoes for woman, then we have getting the same some sort of similar images from the catalog. The same logic that I have used to build this backend functionality of this application. See in our application code, this is a backend, and here I have used this all entire logic inside this image search.py and main.py, which here we have using the fast API to integrate our backend with the front end React, and this is the front end code. Here in this code you can see in backend image simidb. This is the Chroma vector store where you can add the images as the embeddings. These process you can do with the same notebook what I have shown to you, and you can use the same logic to add the vectors into the database, and you can take the copy these vector store and paste it to this backend root directory, and for the inference purpose you can use these applications. So this is the backend code, this is a front end React code. I will share the GitHub link of this code along with this video, you can refer. Finally, we have built an image recommendation engine application with the help of the generative AI embeddings. So thanks guys, thanks for watching this video, and you can subscribe and click the like button to get the further these kind of my experiments I will be uploading soon. Thank you.